Here we want to go into model training. I want to explain to you what is model training, model evaluation, and optimization, which are still parts of machine learning. Now, what is model training? Model training is a process of fitting a machine learning model. We have made mention of different models now. Now, it is now the time to fit that machine learning model to the training data. So after the data has been split into training and testing, then it is now time for model training. So the model training is the process of now fitting a machine learning model to the training data. The goal is to enable the model to learn the underlying patterns. It will be able to learn the relationships and dependencies that exist in that data. Here are the key steps that is involved in model training. These key steps are very important. The first key step is data preparation. That is, when you want to go into your model training, you have to, first of all, pre-process the data. And in pre-processing or data preparation, you are going to be cleaning the data, transforming, and also encoding your features. Another task here is model initialization. What do I mean by that? Now, the model initialization, you have to initialize the model with random or predefined parameter values. Remember that the choice of model depends on the problem and data type, e.g., linear regression, decision tree, and neural network. So whatever model you are going to choose, whether you are going to pick linear regression, decision tree, or even neural network, will depend on what? Will depend on your problem and data type. Another key steps in model training is forward pass. Pass the training data through the model to obtain predictions. In forward pass, for each input, the model will calculate the predicted output based on the current parameter values. Another key concept in model training is your loss calculation. You have to calculate the loss or error between the predicted output and the actual output for each training. So once you have trained your model, you will still go further in your model training. Some of these tasks are very necessary. So you need to calculate the loss. The loss is also referred to as error. So the error that you will want to know, the error that exists between the predicted output and the actual output for each training. So if that loss is much, then it means that your model couldn't perform well. You get? So loss calculation is very important. Now, the common loss function include that you have to calculate include mean squared error. That is, if you are carrying out regression tasks. You can also calculate cross entropy loss if you are doing classification tasks. So what you'll be targeting is that in your loss calculation, you can calculate mean squared error if you are carrying out regression tasks, and you calculate cross entropy loss if it is classification task. Another steps in model training, you get it, is backward pass. This backward pass is also known as graded descent. Now, you need to calculate in backward pass, you calculate the gradient of the loss with respect to the model's parameters. You get it? You calculate the gradient of the loss. After you have calculated your loss, you now calculate the gradient of the loss with respect to the model's parameter. Now, you have to adjust the parameter in the direction that minimizes the loss using optimization algorithm. So your gradient descent is an optimization algorithm. that can help you to now be able to compare your loss with respect to the model's parameters. Another key step in model training is parameter update. Update the model's parameter based on the calculated gradients and the chosen optimization algorithm. The learning rate determines the step size for parameter update. So these steps, you have to keep on repeating them. You iterate the forward pass, the loss calculation, the backward pass, and parameter update step multiple times. You see, this task of repetition or iteration is known as epoch. So the epoch will be used to improve the model performance. So let's assume that, okay, you adjust, you keep on adjusting, you keep on calculating your both backward and forward path. After you are, maybe the first epoch could be 5, then you increase it maybe to 10, 20, until the model improves. So the number of epoch depends on factors such as convergence. What is going to determine the number of your epoch will depend on 1, convergence, computational resources, and training time.